Hello friends, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. Let's jump into today's problem. Rotating the box. You are given an M/N matrix of characters box representing a side view of a box. Each cell of the box is one of the following: a stone, a stationary obstacle, or empty. The box is rotated 90 degrees clockwise, causing some of the stones to fall due to the gravity. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Gravity doesn't affect the obstacle's positions, and the inertia from the box rotation doesn't affect the stone's horizontal positions. It's guaranteed that each stone in the box rests on a obstacle, another stone, or the bottom of the box. Return n by m matrix representing the box after the rotation described above. So basically, we are given with an n by n matrix, and the box will contain either a stone or an empty or an obstacle, right? So each of the cell in the matrix could be any of these three things, right? And what they're going to do is they're going to rotate that box 90 degrees clockwise, right? And when they rotate, the obstacles don't change the position. So the obstacles will be staying same, basically, right? So gravity doesn't affect obstacles, right? So obstacles will not change their positions, but the stones will change the positions, right? So another thing that is mentioned is when the box is rotated, it doesn't affect the horizontal position of the stones, right? So they just fall vertically from where they are into the same column, right? So like that. So for example, I'm going to represent just for the discussion's sake and for the better understanding, right? I'm representing stone with S and obstacle with O and empty with E, right? So that means whenever the stone is present, it has to hit either the bottom of the box or another stone or obstacle, right? So whenever we rotate the box, right, the stone has to hit an obstacle or an empty space, or it should be next to the uh, other stone, right? So any of the three possibilities, right? So let's go and look at it, right? So for example, if the given matrix is like this, SES, this is just for our discussion sake, right? So, but S is represented hash and obstacle is represented star and empty is represented dot, right? But here to better understanding, I'm representing SOE, right? So SES, that means stone, empty stone, right? So that means this stone has to be moved until it hits obstacle or another stone, right? So let's take this empty actually. It has to hit an obstacle or another stone. So that means this stone at 0th position has to be moved down. It has to be moved here. Okay, this one, what is it? It is empty. So this one has to be moved here, right? So so this is what the representation that we want at the end, but let's take this. So when we move the stone to the forward, right, it will become this and this, right? Just for the information sake, that's it. Also, although we want to represent the final result as n by n matrix, right? N by n matrix. So this is what it's going to be. So this need to be transformed to the n by n matrix anyway. That will do it. So, but ultimately, this stone is getting moved until it hits another stone or obstacle, or one more thing is bottom of the box. Bottom of the box. That's anyway granted, right? So if it is, we can't anyway go out of the box anyway, right? That's one thing. And let's go look at another example, right? This one. So where this can move. So let's see, right? So this can move here, right? Good. And after that we have another stone, but this one, right? So we moved the first stone to the empty, right? That becomes, this one, it became empty, and this one became S, and we have another stone here, so this has to move down, right? So right, so now we moved this first stone, and now there is another stone that has to move too, so it comes this. But is it the right answer? Is that the way that it moves? No, not yet. So in that case, whatever we are seeing, so this is not the right answer, not the right one, right? So how we should actually move, right? So we should move from the bottom. So we should not start from the 0th index, but we should start from the n minus 1. So assuming that length is n, so we will start from n minus 1th index, right? So we will have to keep track of what is the empty position that is available next. So initially, we will initialize with the empty position to be n minus 1, right? So here n minus 1 is empty. Yes, it is still empty, right? So there is nothing to be moved. So our index, let's put an index. Index is also n minus 1. Empty is n minus 1, index n. So if index is empty, then we can't do anything. So we do index minus 1, right? Index minus 1. That will be n minus 2, right? So instead of n minus 2 and all that stuff, right? So here we know there are only 4, 0 to 3. Let's initialize 3. That became 2. So index minus minus became 2. So 2, it is a stone, but this stone has to be moved to the next empty position. That means where? To the 3, right? So after moving that, right, what it will become? E, and this will become S, and LT has to be minus minus. That will become what? 2, and index minus minus will become 1, right? Because the index is, we are at 2. So that's good. Now at 1, we have another empty. That's good. We can't do anything anymore, right? So except that we will be subtracting the index again. So it becomes 0. So at 0, you have a stone, right? This stone will move to the next empty position. What is the next empty position? It is 0, right? So index minus minus will become minus 1, and this will become empty, and empty minus minus, right? That will become 1. But index already became minus 1. That means there are no more uh, stones to be moved, right? So that's how we will be proceeding. So this is not the right way, but this is the right way. When you move these 2 stones, they should be going to the bottom, right? Good. But let's look at another example, right? So when there is a obstacle, what happens when there is an obstacle? So here we will be initializing the same, right? It is empty, still 3, right? So what we're going to do? We will be subtracting the index minus 1, right? So it will be same index minus minus, that will be 2. 2 is obstacle. So that means empty cannot be 3, right? So empty has to be updated to index minus 1. So that means empty became what? Index is 2, empty became 1. This is a condition that we need to remember. So whenever we hit a stationary obstacle, right, whatever the empty that was there, we need to update it to index minus 1. That becomes empty is equal to 1 in this case, right? So good. And also we will be anyway subtracting the index, right? So index minus 1, that becomes what? 1. So 1 is empty, right? We can't do any stone, move any stones. Index minus minus, that will become 0. Index became 0. So 0 is having a stone, right? That means where we should move this stone, the next empty position. Empty is 1, right? So that becomes basically this, right? So here index minus minus, that becomes minus 1, right? So let's go. And empty minus minus, right? That becomes 0. But there is index already become negative, so we don't have to move anything. So that's how we have to deal with the obstacles. So now that we know how to do it for single, basically 1 by n matrix, right? So it's all about replicating that for all other rows, right? So assuming the rows as columns and move the index. So this is the logic that we are going to apply. So the only change that we are going to see is this thing, we have to do it for every single row, right? And when we actually make this change, right, we will be doing that in the result array, right? Result array. So input is m by n, right? M by n. But output has to be n by n. That's what it said, right? So this is input and this is output. Simple. That's what we do. So let's look at the code. Simple. Let's follow the code and try to understand the same logic that we have seen. Get m and n first. So length of the box and length of the box of 0, right? So that will give you m and n. And initialize the answer list, basically the answer array with n by m, right? This would do the initialization for answer. So now, as we said, whatever the logic that we discussed, we are going to go from n minus 1, right? Last one, right? So for each row, right, the column will be from n minus 1. Okay, for each row the column will be processed from n minus 1. That means the last element in that particular row. So that's where we are processed. So we care about two things, right? Here, stone and an obstacle. If it is a stone, what we are going to do is whatever the next empty location, we just put there, right? Next empty we have initialized to n minus 1, just like we started, right? When we went through the example, the empty is initialized to 3 and index is also initialized to 3. So in this case, n is 4, right? And minus 1 is 3. So that's what we are essentially doing, right? So here, n minus 1 is initialized to empty. Obviously, since j is starting with n minus 1, that means the index is n minus 1, basically, right? So when we put the answer into the answer array, right, there is some magic that we need to do. So if at all the box of ij is hash means stone. If it is a stone, right? So that stone has to be moved to the next empty location, right? Next empty location. So what is that next empty location? Which is initialized with n minus 1 in the current moment. But it could be changing. So we will be going to that row. So remember, even though input is m by n, we are going with n by m as the output. That's what the requirement, right? So empty became what? So empty was represented as row, even though it was column initially, right? So in the answer, we are going to represent the empty, that is a row, and which column it is going, that is the trick you want to get to. What is the trick? What is the column that it is going to is the question. So which column we are at is the matter. So which column we are at? Generally, in order to calculate the which column we are at, right? Since rows are becoming columns, right? Rows are becoming columns. So that means whatever the row that we have, that is ith row, right? Whatever the row that we have, ith row, that ith row we will be coming down, right? So if you are just go look at the example, right? If this is the ith row, right? That is 0th row and 0th column that is coming to here, so which we don't know yet, right? But how to calculate that? As long as you know the total number, right? As long as you know the total number minus 1, how many I mean the index are starting from 0 to m minus 1, right? So the row index is 0 to m minus 1 and the column index is 0 to n minus 1. So m minus 1 minus I. So that is the location that it is going to, right? So what is m minus 1 is basically that is the row that it will be in the, sorry, that is a column that it will be in the output matrix. So another way that you can think of is, so basically let me type it like this, right? So box of, right, m minus 1 minus I of empty. Simple, right? So this is what it is going to be. But we are going to return the output as n by m matrix. That's why we flip the row and column as simple as that. That's how we are come up with this one. So this will be moved, right? The stone is getting moved, and empty you will have to subtract basically. Why we are subtracting empty? Because we have initialized empty to be n minus 1. That is the last index in that particular row, right? And then one more thing we are going to do here is, since the box is moved, right, that location in the original array need to be updated to the empty one because that is moved already, right? So that's the important step. If you don't do this, then what happens is you have already moved that, and when you encounter that row, that index again, right, it will be problematic, right? So this will be another thing that you need to do. Okay, go. If that is the stone, but what if it is an obstacle? What is it an obstacle? Just like here, if it was an obstacle, right, we just put in updated the empty also, right? We update the index anyway, but we update the empty here, right? That is what we are doing. We are updating the empty. Empty is what? The current index minus 1. What is the current index? J minus 1. And obviously we will copy the obstacle also into the answer, right? Answer. So empty would be the current index minus 1. That's what we did. Empty current index. Current index is what? 2 minus 1 is 1. That's what we are doing. Empty is equal to j minus 1. So it's the same logic that we discussed. We are doing this for all rows. So I is ranging from in the range of m, right? So 0 to m minus 1. We are doing this for all rows. So this is for every row we are doing. That is how we are able to complete the problem. Now, let's look at the time and space complexity for this, right? So time and space. So we all already know the matrix size is n by m, right? So here we have two for loops. So that means we are going to take m by n time. And if you want to call it as n by m, that's also fine. That's not a problem. So that will be order of mn time. The complexity, time complexity will be order of m. And what is the space complexity? So we are given with m by n input, and we are supposed to return a matrix of n by m, right? So answer matrix that we are using. So this is an extra space that we are essentially taking, right? But if you think whatever, since it is required for returning your output, right? So if you take that out of equation, right, then you are using only constant space. But if you consider that towards the space, then it will be order of mn space, right? So we are using order of mn space. time complexity order of m into n, and space complexity also order of m into n. So that's how we were able to solve the problem basically. So if you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. Thank you for watching. You'll be able to find several playlists regarding various categories of the problem, such as BFS, DFS, dynamic programming, stacks, queues, and linked lists. Please check them out. If you haven't subscribed to my channel, please go ahead and subscribe and share also among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thanks again for watching. I will be back with another problem very soon. Till then, stay safe and goodbye. Thank you very much.